Okay, yeah. This background noise is coming. So when you want to interact, just unmute yourself and just interact with me. Is it fine? Hello.
Yes, sir.
Okay. Yeah. You can mute while you are listening, and you can uh, anything if you want to interact. So just unmute yourself and interact with me. Okay. So today we'll discuss about FIFO. Okay. So last session we already seen the FIFO. So FIFO is about what is FIFO? It's a sequential memory, na? It's a sequential memory and
Hmm.
first in first out. First in first out. Okay. So this is a FIFO. So where you are using FIFO means so if you take the block diagram. So this is a FIFO. You have clock, okay, and next reset and data underscore in and write enable, read enable, read enable, and next you have empty, full, and next data out, data underscore out. Okay. Suppose if it is 16 cross 8 before, so total how many locations will be there? How many locations will be there?
16.
16 locations will be there. Okay. So 16 locations. So this is 0, 1, 2, 3, again 12. Okay. Like 13, 14 and 15. Okay. Like the total 16 locations will be there. So can you say the difference between RAM and FIFO?
Sir, in RAM, any location can be accessed, but maybe FIFO, as per the names prescribed, the first bit stores that can be extracted first, like that.
Okay, okay, yeah, you are correct only. But coming to the block diagram, what is the difference I'm asking? We already seen the RAM design, no? We
Sir,
already seen the RAM
em-
design. Hmm.
we have a empty output, empty
Empty, yeah.
signal
This is the
signal
empty
also,
signal. Okay, this is
but it
one
was
bit
not in the RAM.
in
Yeah,
the RAM. Full also not there. And next,
yeah.
so one difference is empty and full. This is
Full.
added. Okay. Tell me one more
Address.
difference. Yeah,
Address.
yeah, address. So in RAM you have write address and read address. Okay,
Right address, read address.
but in FIFO you don't have the write address and read address. Okay, so why?
Yes,
Because
yes.
this is a sequential memory. Sequential memory means one by one serially we can load the data in the FIFO. Okay, serial we can load the data, that is the FIFO. Okay, and there are two types of FIFOs will be there. One is synchronous FIFO. Synchronous FIFO means common clock will be there. Common clock, only one clock will be there. And next is asynchronous FIFO.
Asynchronous FIFO.
Asynchronous FIFO means there are two modules are there. So two modules will be operating at different clock. Okay. So here different clock. This is separate topic. Different clock. This we call as what? CDC. CDC means clock domain crossing.
Crossing.
Clock domain crossing. Okay. So two modules operating at different clock, that we call as a clock domain crossing. Okay. So where we are using FIFO? Where you are using FIFO? Suppose like if you take two modules. Okay. Let us take this is module A and next is module B. Okay. So module A and module B. So these clock frequency is same only, synchronous FIFO. Okay, so these both are operating at same clock frequency, but frequency of this module A is 100 megahertz, and this frequency of module B is 50 megahertz. So this is operating at high frequency, and this is operating at low frequency. So this is high frequency. So this is high frequency, okay, and this is low frequency. So when you want to transfer some data between module A to module B, there is a chance of what? Data loss. No? Suppose module A is high frequency operated, means you can consider a microprocessor or microcontroller or some DSP process. Okay, this will be operated at high frequency. Okay, and module B is some peripherals like ADC or RAM. Okay, or ROM. These are low peripheral, low devices, peripheral devices. There is some data loss. Okay, so in order to avoid that data loss, we need to keep the FIFO in between module A and module B, such a way that whatever this FIFO is there, this will hold the data for some amount of time. So like it's like a buffer only. So after some amount of time, whatever the data is there, that will be passed to module B. Is it fine? Did you understand?
Sir, just repeat last few lines only regarding this buffer.
Actually,
This
this is
role of
actually like
role of this buffer.
buffer means what? Here, just you are holding the data. You are holding the data for some amount of time. Whatever the data is there, you are transmitting from. You are keeping from module A, and after some amount of time, it is transferring to module B. Okay. So, like in, I think you already studied 8086.
Yes.
FIFO is
Yeah,
actually,
it's a processor.
it's a processor. It's a queue
Uh,
only. Okay. You have like in the architecture, you have two types, no, bus interface unit and execution unit. Okay. So in the bus interface unit, like there are 6 bytes of queue, no, 6 bytes of queue will be there. 6 bytes of instructions are available. Okay, and this is one type of parallel processing. So when execution completes, so next instruction is ready to. It will be fetched to the execution unit. So like that, in order to avoid the data loss, we are using this FIFO. Is it fine? Did you understood?
yes, sir. Partially, but it's okay. We will study.
What about others?
Yes.
Okay.
Yes, sir.
Yeah. First, today we'll discuss FIFO. So I told you two types of FIFO are there. No? So today we'll discuss about FIFO depth calculations. Okay, this is interview point of view. These are very important. Okay,
FIFO.
FIFO depth calculations. Okay, next class we'll go with the coding part. Uh,
Yes.
so FIFO depth calculations. FIFO depth calculations. Okay. So in the FIFO depth calculations, you have total 10 cases are there. 10 cases
10
are there.
cases.
10 cases. Okay.
Yeah.
So what are those cases? We'll see. Okay. Suppose if you take F write, F write is what? It's a writing frequency, and F read. F read is a reading frequency. Okay, reading frequency. And suppose there are some formulas are there. Time taken, time taken to write to the FIFO. To FIFO is if you take the data size, how many bits of data you are sending, the data size is D. Okay, that is in terms of data words. Data words. Okay, here D by F right. This is the formula. D by F right. Is it fine? D by F right. Okay, this is a formula for time taken to write into FIFO. Okay, and coming to data read. Data read from the FIFO. From the FIFO in the same time. The same time is D by F right into F read. F right into F read. Okay, and excess of data or FIFO depth. Excess of data or data is a FIFO depth. Okay, this we call as backlog also. Okay, backlog. So backlog. So backlog equal to what? D minus D by F right into F read. Is these formulas are fine? So FIFO depth equal to what? FIFO depth equal to backlog.
Sir, please elaborate the third line from the bottom.
Data read. So time taken to write into FIFO. So this is actually time taken to write into FIFO is D by F right.
Not that one. No,
Uh,
not that one.
Data read from the FIFO in the
Data
same
read
time is
from.
D by F right into F read. Formulas. These are the formulas.
Sir, that mean time taken to write to FIFO and data read from the FIFO in the same time.
Hmm.
These time are equal in
Equal.
the
At same time. At same time it should read the data. This minus this D minus
quantity.
this value will get the
Quantity,
backlog or backlog or FIFO depth.
but quantity wise, these are not the equal, na?
No, not equal.
Because F read is multiplying, na?
Otherwise, without formulas also we can do. So just this formulas you remember. Uh,
Sir, time taken to write to FIFO is time taken to write in all locations or one location, sir?
Time taken to write to FIFO all locations.
Okay, that is
Hmm. Hmm? Okay.
yes. So F rate is frequency for writing, sir. Like F rate is what?
F right is actually I told you no, like two modules will be there. So this is so module A and module B is there. Okay. So module A and module B means this is F right frequency of this is writing frequency and this is reading frequency.
Yes. So in
Okay.
between FIFO will be there. So that is why F rate is there,
F
right?
right is there. Yes.
Okay.
Okay.
Uh,
So
Sir, Adarsh asked that time taken to write to FIFO equal to D by F, right? So
uh,
this was for all locations, right? Okay.
yes, all locations.
So the number of locations must be multiplied with this thing.
Data by F right. This is the formula. Or otherwise, with formulas also I can explain you. So if it is like difficult to remember these formulas means, I will tell you without formulas also I can tell you. Suppose if you take case one.
Hmm.
So case one, you have module A and next module B. Okay, module A and module B. Okay, so here module A is transmitting the data from module B and F write is 80 megahertz and F read is what? F read is let us take 50 megahertz. Okay, so this is writing frequency and this is what reading
Reading
frequency.
frequency.
Okay, so reading frequency, and they given the uh, data size. Data size is 120. 120 data size. Okay, 120 is the total number of data items should be transferred. This many data items should be transferred from module A to module B. Okay,
So
now
120 bits.
120 bits, yeah, 120 data words. Data words. Okay, data words should be transmitted from module A to module B. Okay, now what is the time taken to write the data? TA equal to how much? 1 by 80 megahertz, no? Frequency and time both are reciprocal, no?
Yes, sir.
Yeah,
So
yeah,
time
yes.
equal to what? 1 by f, no? Okay. So this is 1 by 80 megahertz means you are getting, this is 12.5 nanoseconds. Okay. So this is the time taken for writing
Operation.
one data word. Okay, this is the time taken for writing one data item or one data word. Okay, now time taken for writing 120 data items.
120 into 12.2.
They multiplied with
12.5
12.5
nanoseconds into
into 120,
120.
120
Okay,
data
so this
words.
is how much you are getting, 1500 nanoseconds you are getting. Okay, 1500 nanoseconds you are getting. Okay, let us take TB. TB is what?
1
Time
by
taken
50.
for reading one data item.
One data item.
Okay, so this is
1
equal to
upon
how much?
50.
1 by
1 upon 50
50
megahertz.
megahertz. Okay, so 1 by 50 megahertz. So this is how much? 20 nanoseconds you will get.
20 nanoseconds.
Okay, so that means 20 nanoseconds it will read one data item. Okay, within 1500 nanoseconds, how much data items it will read? Let us take this is X. What is X? You tell me.
Sir, 1500 divided by 20.
1500 divided by 20. Okay, so this is equal to how much? 75. Okay, 75. This many data items will be read. Okay, will be read. Okay, actually module A is trying to transfer how many bits of data? Tell me.
120
120.
data.
Okay, 120. But due to this difference in frequency, module B can receive or can read how many bits of data? How many
75.
data items? 75. Okay, so there is a data loss, no?
Yes, sir.
Yes.
So how much of data loss? 120 minus 75. How much?
So it's around 85,
45, no?
95, 45.
45.
45. So this many data items will lost. Data items will lost. Okay. So what is the FIFO depth?
120.
45.
Before
You
depth.
need to in FIFO depth.
Okay.
FIFO depth means you need to insert a FIFO having a depth of how much? 45 location.
Okay.
Okay, we are doing this calculation to get the depth. Okay, sir.
Okay,
Got
sir. Understood.
Understood?
it. Yes.
Okay. Next case 2 you take. Case 2. Case 2. uh, Given FA equal to 80 megahertz and FB equal to 50 megahertz. Okay, and data items also he given 120. Okay, ideal cycles, ideal cycle between consecutive write equal to 1, ideal cycles between consecutive read equal to 3. Okay.
Sir, not understanding, sir.
Yeah. Ideal cycles and run
Ideal
time.
cycle
Right.
from.
This one okay, no? So previous case only.
Yeah, this one
Okay.
okay.
Yeah.
Yes,
So
yes.
ideal cycle between consecutive writes means suppose let us take this is my right cycle. Okay. So this is my right cycle. So what is happening means here like in this cycle right is happening and next cycle it will be idle and next cycle right operation is happening again idle, so again idle. So within how many cycles the right operation is happening?
Two,
For every two cycles,
One right is
right.
for every two cycles one right operation is happening now. Two
Hmm,
cycles
hmm,
one
hmm,
right operation. Okay. And next ideal cycles between consecutive reads. So that means if you draw the waveform for read, so
hmm.
you take the read operation. So here read is happening and how many idle cycles? Three idle cycles. And
Hmm.
after that one more read is happening. So for every how many cycles?
four cycles, one read is happening.
For every four cycles, one read operation is happening. Okay, read operation. Okay. Now you can
Yes,
calculate, no? So what is
yes.
TA?
Uh,
1 by 80 megahertz into 2, no? Why? For every two cycles, one write operation is happening. FI is actually writing frequency. FB is actually reading frequency.
Yes.
Okay. So how much
Sir,
you will get?
do we need to multiply it with the nanoseconds now, sir? Like two cycle as in it will be okay, 2 nanosecond only.
Into 2, 2.
Yes, sir. Okay.
25 nanoseconds. Okay. And
Yes.
TB equal to how much? 1 by 50 megahertz into 4. How much you will get? Before this, this is writing one data item. This is for writing one data item. Okay. TA is writing one data item. For 120 data items, for writing 120 data items, how much? 25 into
1 by 80.
120. 25 into 120 means how much you will get?
Okay.
3000 nanoseconds. You will get. Okay. 25 nanoseconds into 120 means 3000 nanoseconds. And next,
Sir, I am little unable to understand why we are multiplying with 2, 1 upon 80 megahertz into 2. So
why? Because
this
here
in,
every two cycles write operation is happening. No, for every
uh,
two cycles, he given the ideal cycles between consecutive writes is one. So every two cycles, one write operation is happening. That's why this time I need to multiply. That is actually time equal to one by frequency. Here previously there are no ideal cycles. Okay, that's why we already took TA equal to 1 by 80 megahertz. But here there
hmm.
are some ideal cycles are there. So every two cycles, one write operation is happening. That's why I am multiplying this TA with 2.
Sir, the upper waveform is for what this waveform is?
Right, right cycle.
Right operation,
Uh,
right cycle.
this is read cycle.
Uh,
Simple. Just every two cycles, the write operation is happening. So that's why you need to multiply. This is TA equal to 1 by 80 megahertz into 2. Okay.
okay.
Similarly, like TB equal to how much? 1 by 50 megahertz
Into
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 4.
4. Okay. How much you will get? How much you will get? 80 nanoseconds you will get. Okay. So 80 nanoseconds is reading one data item. 3000 nanoseconds, how much?
3000 by
3000 nanoseconds
by 8.
by
8.
80 nanoseconds. Okay, how much you will get?
38.
37.5. You can approximate the data items to 37. Okay, so this many data items will lost.
Will
Okay,
be
so 120 will be read. Sorry, this
read.
many
Read.
read. This many data items will read. Okay, so 120 minus 37. How many data items before depth? 83 locations.
83.
Okay, this is my before depth.
Sir, data items means data word, right?
Data
The
words. Data words.
what
Yeah. Data
word.
word.
And
Previously I told you.
sir, here word will be, that means 16-bit width.
Not 16-bit, bytes only. Suppose if you take previously, we took the FIFO as how much? FIFO as previously I drawn. No? Let us take this is 16 cross 8 means
Plus 8.
8 bits, 8 bits, 8 bits of data,
Hmm.
8 bits of data. Is it fine? 16 cross 8 means what? Each depth is 16 locations. Width is how much?
8.
8
Uh,
bits. 8 bits.
8,
Okay.
8
Yeah.
bit.
8 bits. Okay. Case 2 is fine.
Yes.
Yes,
Okay.
sir.
Yes,
Next,
sir.
coming to the case 3. Case 3, they given the writing frequency is 80 megahertz and reading frequency is 50 megahertz, and next data items is 120. This is writing, and they given the duty cycle of write enable equal to 50%, duty cycle duty cycle of read enable equal to 25%. So you duty cycle you know. So that means this is equal to how much? 1 by 2, no?
Yes.
This is equal to 1 by 4. Okay. So that means in every two consecutive cycles, in every two consecutive cycles, one write operation is happening. One write operation. Okay. And in every four consecutive cycles, one read. This is same as case 2 only, no?
Yes, sir.
Same as case 2 only. Is it fine?
So then combination of case 2 and case 3 will be coming. Right?
Yeah, it is same as previously case 2 we already seen, no? Ideal cycle between consecutive write is 1. So that means every 2 cycles one write operation is happening, and every 3 cycles one read operation is happening. So they given in terms of duty cycle.
Okay.
Okay. So duty cycle is 50% means 50 by 100. So 50 by 100 means how much? 1 by 2. Okay. Here 25 by 100. So 25 by 100 means 1 by 4. So every 2 cycles, one write operation is happening. Every 4 cycles, one read operation is happening. This is same as case 3 only.
Yes, sir.
Is it fine? Did you understood?
Yes, sir.
Okay. Next, case 4. Case 4. Okay. FA equal to 30 megahertz and FB equal to 50 megahertz and D equal to 120 data items. Now tell me, is FIFO is required?
No.
Why?
because the frequency of output is more. So
Writing frequency is
more.
lower than the reading frequency. When FIFO is required, writing frequency is faster than the reading frequency. Writing frequency is larger than the reading frequency. So here writing frequency is slower than the reading frequency. So normally FIFO is not required. Okay. Suppose if FIFO is required, so if FIFO is not required, if FIFO is required, you need one depth. FIFO of suppose if we need a FIFO, if we need a FIFO, so we need to design. We can take one location. We can take one location. Is it fine?
Yes, sir.
Okay. Now next case 5.
Sir, the last statement I didn't understand. We can take one location.
One location we can take. Before depth of one location we can take. Within that location, just data will be placed. Okay. Here module A and module B is there. So within this location, data will be placed. From this location, data will be taken.
So it is like
Sir, as
that that FIFO is not present. It will be like that FIFO is not present.
Not present. Yes. Yes. Okay.
Sir, as it is a little new concept for me. So, as I understood, if writing frequency is less as compared to reading frequency, so we have no need to deploy a FIFO here.
Yes. Yes.
And if we have to deploy, we can use only single location.
Single location. Yes. So when the FIFO is required, I told you, starting only I told you. So when the FIFO is required, let us take two free.
To
Uh,
compensate the
so,
both frequencies.
I told you two modules are there. So
Huh,
one module is operating at high frequency, another module is operating at low frequency. So
huh,
module A is trying to transfer the data from module A to module B. There is a
huh,
chance of data loss. There is no, actually, this is for synchronization purpose only.
hmm,
Both are operating at different frequency. There is no synchronization. So
hmm,
that's why there is a chance of data loss. So
hmm.
we need to require a FIFO in between module A and module B. Is it fine?
Fine, sir.
Yes.
So interview point of view, this is very, very, very important concept. They will ask the FIFO depth calculation. Okay. Once
Hmm,
you go through this. Okay. FA is case 5. FA is 30 megahertz and FB is 50 megahertz and data rate is 120, and they given the ideal cycle between consecutive write, consecutive write, this is equal to 1. Ideal cycle between consecutive read equal to 3. Now you can find out, no?
Yes, sir.
Yes, sir. But in this case, we don't require a FIFO, no, sir.
Here we require a FIFO. Why? Because they given the ideal cycles. So we require a FIFO. Okay. Now TA equal to how much? 2 into 1 by 30 megahertz. Okay. So this is equal to how much? 66.66 nanoseconds you will get. And TB equal to 4 into 1 by 50 megahertz. Okay. So this is equal to 80 nanoseconds you will get. Okay. And 66.66 into, this is for one data item. For 120 data items into 120. So this is how much? 8000 nanoseconds. Okay. So uh, so 80 nanoseconds for one data item. 8000 nanoseconds, how much?
8,000.
X equal to what?
8,000 by
8000 nanoseconds by
8.
80 nanoseconds. So here you are getting how much? 100.
100.
100.
Okay. So what is the FIFO depth?
100.
20.
20. 120 minus 100. This is equal to 20. This much of FIFO is required. Is it fine?
Yes,
Sir,
sir.
doubt actually.
Hmm.
The ideal cycle between consecutive rate cycle is only one. If
Hmm.
we take that also, uh, reading will happen at a slower rate, no, sir, because there is like three ideal cycle between each read signal.
Hmm. Hmm. Hmm.
So my doubt is that why in this
Actually,
case we,
ideal cycle here one. Reading cycle is three.
reading is happening at a slower pace compared to right now, sir. Like in this
Very slower case. Yeah, yeah, yeah.
Yeah, my doubt is that in this case, the input frequency is 30 megahertz, reading is 50 megahertz. Why didn't we require a FIFO in the earlier case, but in this case we require a FIFO?
Here, actually, like even though there is a less frequency and there is a more frequency, previously there are here in this case there are no idle cycles.
Yes, sir.
There are no idle cycles. So if there are no idle cycles means anyway like this is less frequency means so there is a no chance of data loss. Okay, but here what is happening? There is some like reading is happening every 2 cycles and writing is happening for every 4 cycles. Okay, so idle cycles are there. There is a chance of data loss in this case. So the data loss we need to find out. How much of data loss? 20 is the data loss.
So basically, in the previous case, there were no resting.
Yes, yes.
Every
No
cycle
idle.
it will be sending, but in this
Ah,
case, uh, there is a idle, means
idle.
there is a free time.
Hmm.
That is why.
Sir, actually, still my doubt is not cleared actually. Like every two cycle, let's take at t equal to 2, one data will be written onto the FIFO.
Hmm.
At t equal to 4, second data will also be written, uh, and the read signal can also happen parallelly. So the module A can directly write to module B, no sir. Like maybe I'm not understanding correctly, but
But here there is a delay in the reading only, no? Suppose if you take this writing cycle here, what is happening? So here writing is happening. Next cycle, what is happening? There is a idle, nothing
Either.
is happening. And next cycle, again writing is happening.
yes, sir.
Okay. And here in the reading, what is there? Suppose reading is happening here. It will be idle for how many cycles?
4 cycles.
3 cycles.
Sorry, 3 cycles.
Three
Four.
cycles, and next fourth cycle, and one more read operation is happening. So compared to writing, the delay is more. No, reading delay is more. No? Here only one idle cycle, but for reading, how many cycles delay? 3 cycles. No.
Yes, sir. Maybe I still have doubts, sir. Maybe after class, if possible, can you teach this
Yeah,
case?
yeah, yeah, yeah. I will look into this and I will tell you. Okay, yeah.
Yes, sir.
Uh,
Sir,
so
I'll
next,
also join, sir,
okay.
because feeling some partially difficulties to understand
This is means it's a like new concept.
new concepts, sir.
New concept. I
Because
think.
our faculty not introduced with this thing.
Yeah, yeah.
So
So interview point of view, this is important before depth calculation.
definitely, sir.
Uh,
Even I tried to understand the doubt asked by Siraj and Adarsh.
uh,
So even I was unable to catch what the problem they are asking.
okay.
So and network is also making problem here.
Suppose the case 7, if you see, uh, suppose if it is case 7, f right equal to 30 megahertz, f right equal to 50 megahertz, and f read equal to 50 megahertz, and data words is 120. There are no idle cycles. No idle cycles. Is FIFO is required?
No, sir, because they are operating in the same frequency.
FIFO is not required. Okay, in this FIFO is not required. Uh, Not required if both read and write, read and write, are in same clock. Okay, read and write are in same clock. Okay, so same clock phase. Suppose read and write are in different clock phase. Read and write are in different clock phase. Then one FIFO of one depth is required. FIFO of one depth is required. One depth is required.
Sir, what is this written read and
Read and
write?
write in, suppose here, see here, suppose this
Uh,
is read cycle.
no,
Okay.
no, what is, I'm unable to read the word read and write am different.
R.
Read and write are in different phase.
Okay, okay, indifferent.
Different phase. So when read and write are in different phase, different phase,
Different
then
phase.
FIFO depth of one is required. One is required. Is it fine?
Sir, what is meaning by being in different phase?
Yeah. See here, like this is writing frequency,
Hmm.
writing cycle.
Hmm.
Same phase means what? These are, so whatever the writing frequency and reading frequency are operating at the same phase. This is actually same phase. Okay, this is actually same phase. Different phase means what? Here, suppose this is writing frequency. So this is writing frequency, and suppose reading frequency will start from here.
Okay, okay, okay.
There
There
is
is
a
a
different phase, no?
difference. Hmm.
There is a
But sir,
different.
in the case six, writing and reading frequency are same, and but have a different phase.
Hmm.
Frequency, numerical value of frequency is same,
Hmm.
but phase is different.
Phase is
So,
different. Then
so
FIFO of
one
depth is
one
required.
depth one is required. Okay.
Required. Okay.
Sir, but I have a doubt here. Like
Uh,
FIFO is not required if no idle cycle, but we have taken in the case of if writing is slower compared to reading. At
uh.
that time, we have used one bit one depth FIFO. Why
Uh.
there and why not here?
That is lesser, no? This is here. We seen lesser
Uh,
frequency. Hmm.
so this case and that case is actually similar, right? It
It's
should be similar.
it should be similar. So it means
But
writing
here we are
frequency.
using a FIFO, one depth FIFO. But in this case, even though it is similar frequency,
Hmm.
which is like we don't need anything. Here also that one bit FIFO should be used when no idle cycle. Right?
Yeah, here, so if it is different phase is there, one depth
No, no.
FIFO is required.
In the same clock itself, I am asking. In
In
the
same
same
clock
clock.
itself. In same clock itself means here both are operating at same frequency, no?
Uh,
Both are
so it
operating at same frequency means synchronization is happening. There is no chance of data loss.
so can you go to the case three? Case previous case. Not this one, sir. Case two, I
Yes.
think. Four, I think. This
Hmm.
one, this one. So here we need to achieve the synchronization. So that is why we are giving that circuit of
Hmm.
one bit.
Hmm. Hmm.
Okay, okay. Understood.
Next, case 8, FA equal to
Sir,
50
case
megahertz.
7.
Case 7. Okay.
Case
1 second. Case 7. Case 7.
Yes.
Case 7, FA equal to 50 megahertz and FB equal to what? 50 megahertz. Okay. And idle cycles they have given. Idle cycles, okay, between consecutive writes is equal to 1. Idle cycles between consecutive reads is equal to 3 they given. Now you require before depth calculations, no?
Yes.
So TA equal to how much? 2 into 1 by 50 megahertz.
150.
50 megahertz, so you are getting 40
Into
nanoseconds.
D.
Okay. And TB equal to
Sir, into D.
uh,
D is not required.
TB is required 4 into
No,
1 by
D data.
data is how much? 120 they given. Okay.
So you didn't multiply that.
Multiply, yes. Okay. So this is 80 nanoseconds. Here I am multiplying 40 into 120. So this is equal to how much? 4800 nanoseconds. Okay. So 80 nanoseconds for reading one data item. For reading 4800 nanoseconds, how much? X equal to how much?
60.
4800 by 80.
60.
This is equal to 60. Okay. So what is FIFO depth?
60.
FIFO depth equal to
120 minus 60.
120 minus 60. This is equal to 60.
60.
Okay. Is it fine?
Yes.
Fine, sir.
Okay. Yeah. Case 9, they given in a different way.
Case 8, right?
Case 8. Case 8, they given in a different way. FA equal to FB equal to, let us take same only 50 megahertz. Okay. And writing data they given in a different clock, like a different way. 80 data out of 100 cycles, 100 clock. In this, what are randomizing? That means 20 data are randomizing. 20 data are randomization of 20 data. Okay, randomization of 20 data. And coming to the outgoing data, that is read operation. Okay, outgoing data. You see the outgoing data. So outgoing data is 8 data items out of 10 clocks. Okay. So this is the case. They given in a different way. Okay. Did you understood? Suppose if you take the case 1. Okay. Case 1 if you take. So writing will happen from 0 to 80 cycles, 80 clocks, and 20 will be idle, and again this is up to 100, and next to 20 will be idle. So this is 120. Again from here to here 120 to 200. Okay, these are varieties operation. This is one case. Did you understand case 1?
So this case 1 is inside the case 8. Is that
Inside
like?
the case 8, different cases will be there. That's what I am explaining. Okay.
So naturally it should be right idle, likewise only.
Right idle. So writing is happening for 80 cycles, and 20 cycles it will be idle. Again next 20 cycle it will be idle. Again next write operation is happening. Is it fine?
Sir, what is this 80? 80, 100, 120 is a megahertz frequency.
Data items. The given
Data
is
items.
data items.
Sir,
Okay.
so the writing frequency is more than the reading frequency based
No,
on
both
this.
are same. Both are same. Both are same. We are seeing the different cases. Why? Because here they given the in terms of writing data and outgoing data. So writing data, what they given. So out of like 100 clock cycles, 80 data will be there and 20 are randomized. 20 will be like randomized. Different cases we can take. Okay. And reading data also, out of 10 clock cycles, 8 data will be there, and 2 will be randomized. Like that, he is giving in a different way.
Okay.
Okay. And next, if you take the case 2, if you take the case 2, so case 2, like this is idle, and next is right, right, and here this is idle, and next this one is right. Okay. Here 0 to 20 and 20 to 100 and 120 and 120 to 200. Okay, this is the second case. Is it fine?
Yes, sir. So
Case 3.
right now you're writing different possibilities that can be happening for right.
Yes, yes,
In
possibilities I am taking. Why?
okay.
Because 20 is randomized,
Yes, sir.
Okay. So this is 0 to 80. So this is right operation, and next again this is idle, and next here one more right operation. So 80 to 100 and 180, and next here one more idle. Okay, 200. Is it fine? Case 3.
Yes.
Okay, and next case 4, if you take, first 20 cycles will be idle. Okay, first 20 cycles will be idle, and next right operation is happening till 100, right operation, and next right operation is happening so till 180, 180 to again 200. This is idle cycle. Okay, and next case 5, like random cycles means, suppose 20 you can divide into how many types, how many parts. Suppose in terms of
Two
if you take
types.
5 cycles are idle, how you can divide? Tell me how you can divide. 4 3 4 3, next 3, these are, or 4 cycles you take. Okay, 4 cycles means 4 cycles will be 5 cycles means 4 4 4. Okay, 4 4 4 5 are 20, no? So here 5 cycles means, like here 0, here right operation, 4 cycles idle, again right operation. Okay, here right operation, again here right operation. These are the idle cycles. Okay, so this is right operation, this is right operation, and this is right operation. Okay, like this 5 cycles will be idle. Okay, 5 fours are how much? 20. Okay, or otherwise till 100. Again, if you take this, so like 7 cycles are idle. Okay, again right operation. Okay, again 7 cycles are idle. Okay, again right operation, again 8 cycles are idle. Okay, so this is the different cases I wrote. Okay, so here if you take the one second, so cases, if you take the cases, so I am writing case, and next number of cycles to complete the right, number of cycles to complete the right. Tell me for first case, how many cycles are required? Tell me. Case 1.
4.
80.
200.
Okay.
Number of cycles, how many are required? 200,
200.
no? 200. Okay. And case 2,
It's 200.
200. Okay. Case 2 is 200. Okay. And case 3,
180.
180. Okay. Case 4,
180.
case 4,
180. 180.
160, no?
How come, sir?
First is ideal cycle. Next is ideal cycle. 180 minus 20, how much?
Oh, like this. Okay.
160, no? Okay.
Yeah.
And case 5, this is 200 only. Okay. 200.
Sir,
Okay.
in that case, case 2 will also be 160, no, sir,
No,
because
But
like if
here
that is the
we need to
case
consider
2 also 8 plus 80.
actually. Uh,
Case 2. Case 2
case
will be
2 also,
180.
case 3 also,
Sorry,
it will be
160.
no, no. Here you see case. One second. Case 2. We need to. It will start from 0, where it is ending the right cycle. 200, no.
Sir, but we are calculating only for right, no, sir. So only right.
Actually, here it will start from 0. So when the right ends, we need to take out.
Okay,
so
sir.
in the case 4 also it is starting from 0.
Case 2 it is 180, no. Case 2 it is 180. Case 3 180. Case 4 160. And
Okay, then it's
case
both.
5 200. Okay.
Okay, sir.
So we need
Sir,
to consider.
actually, case 2 is 160 because 20, like, first it will take 80 clock cycle,
Hmm.
then again 80 in the second right, 80 cycles,
What I am
something.
telling here, we need to take the last cycle for right.
Ah, no, sir, case 2, sir. Case 2.
So it is
Case 2,
starting
last
from 20
cycle.
only.
Case 2 is 200 only.
200 minus 20, right?
200 minus 20, 180 will get.
Yes.
Sir, what
I mean,
about the idle cycle in between, sir? That
Ideal
20
cycle
also.
will be counted. Ideal cycle will be counted for right. Here case 4, if you take ideal cycle, actually here ideal cycle, here this is 180 minus 20 means you will get when ideal cycles are in between, that will be counted. When it is starting, it should be detected. That means this will be 180. Okay.
Okay, sir.
So for considering this, you need to take the worst case. That means how many maximum number of data those are means lost. So what is the worst case? What is the
160
worst
case
case?
4.
What is the
among
worst case?
all the cases are
Uh,
200. I mean,
Case
most.
4.
Case 4, no, 160. Why? Because 160. So 160 actually 40 amounts of 40 data is lost. No,
Cycles.
40 data is lost. We need to see the worst case.
Okay, sir.
Okay, we need to consider the worst case. Okay, so here if you see like case 9, so what is case 9? So out of 200, so we need to consider the worst case. Okay, that is what case 4 we need to consider. Okay, so that means out of 200 cycles, 160 data items are written. Okay, so that means for writing we need to consider maximum data loss. Okay, maximum data loss, and for reading minimum data loss we need to consider. Okay, so that means here so 160 clock cycles is the worst case. So 160 160 into 8 divided by 10. Okay, so this you will get 128 read data. That formulas I am applying. Okay, so total FIFO depth is how much? 160 So let us consider 160. 160 minus 120. So this is 120. Here you will get 128 data items. So 160 minus 128, you are get 32 data items.
So can we go to the original question like first before writing all the cases?
Original question means this question you are asking.
Ninth case starting.
Which one?
Sir, based on this, okay, 200. mm,
Okay.
Sir, to get the max data, we need at least 200 clock cycle. That is
Hmm.
what is mentioned in the question, sir. Like, we need
Ah,
at least 200 clock cycle.
200
Just
clock cycles. Yeah, 200 clock cycles. Okay. Yeah, yeah. Okay, this you analyze. I have one more class. We will discuss. Okay.
yes.
Hello. I'm joining, sir. I mean, previous class. Okay, I'll join. Hmm. Just to go through this, we'll discuss in the next class.